Once we understand the ratio on these three triangles, the one that give us 30, 60, 90, or 45, 45, 90, or 60, 30, 90, we can now use these three triangles to find the ratio for each of them, like the sine ratio, the cosine ratio, and the tangent ratio with angles bigger than 90 degrees. In example number 1, I have theta equals 135 degrees. And this is an angle in standard position, measuring from the positive x-axis. 135 degrees goes beyond 90. It goes beyond a right angle. And in fact, it will go all the way to the middle in quadrant number 2. This is 135 degrees. How do I know that it is right in the middle? This 35 degrees is 45 degrees beyond 90. But once again, in math, we don't use the y-axis to create your angle. We would use the x-axis here to describe the location of this terminal arm. And we call this having a reference angle of 45 degrees. Because this 45 degrees came from the fact that it is not quite 180 yet. This is 180 degrees. But the angle between the terminal arm and the x-axis is what we will get for the reference angle. So in this case, the reference angle is 45 degrees. Once you have this 45 degrees, you can then create a right triangle without using a calculator and come up with the side length on this triangle. So let's say if I continue with this triangle, this is my triangle, 45 degrees here, then what I can do is to label the triangle with 1, 1, and root 2. So this will be the ratio between these three lines. Now of course, some of you may find it a little bit confusing with a positive 1 on this side. In fact, this line will now be a negative 1 if you consider this line on the x-axis. The line that points to the left-hand side will now give us a negative value, and which means the ratio for your cosine and your tangent will now be negative, because your adjacent side for this triangle will now give us a negative length for the adjacent side. But we're going to spend more time on this later in lesson number 2. In the second lesson, lesson 2.2. That's what I meant. But for now, we're just going to look at the size of the other three angles in quadrant number 1, quadrant number 3, and quadrant number 4. If I'm to use this reference angle to come up with another terminal arm, how big would this angle be? Or where is this terminal arm? Here. If you are to start your measurement from 0 degree again, and you are to turn all the way to this terminal arm, how big is this angle in the third quadrant? Copy?
Why is that 35 degrees?
Why is it 35 degrees? Oh, no, it is 135 degree. it is 135. Here, let me erase this one. I was to use this to indicate 135 degree for this terminal arm. Yeah. The line probably make the one hard to see. So this was the terminal arm. Now this time when I turn this terminal arm to the third quadrant, having the same reference angle here, how big is this angle in quadrant number 3? (225), yes. The angle in the third quadrant is now 45 degrees beyond 180. So that will give us 225. What about the one in the fourth quadrant? If you are to measure this angle starting from 0 degree and have it go all the way to this quadrant, 315, yes. Quadrant number 4, this angle is almost, it is so close to 360, but it is not quite there yet. It is 45 degrees off from the 360. So that would give us 315. What about the terminal arm in quadrant number 1? What would be the angle in standard position for this angle? 45. In this quadrant, the reference angle will be the same as the angle in standard position. So that's basically what we've talked about in the previous lesson. And once we understand how different angles will give us the same reference angle, we can now use SOHCAHTOA to solve these angles, to solve these triangles without using a calculator. We'll be using the special triangles to solve different things.